606 Phase 2 presentation. For this EDA presentation, I would use Apple's stock price data from 2008 through 2009 as a demonstration. The first step is to look into the statistic characteristic of the data. Stock price data usually is non-stationary, which means the mean or the standard deviation would change over time, and it is highly seasonal, means different season might have different behavior of the dataset, and it has trend and detrend. And also stock price have many random noises that could be come from another factors like news or 10K reports that comes on that day that might affect the price. So I did a little bit of seasonal decomposition of my time series. So a time series could be a multiplication of the trend times the circle of the time period times the seasonal behavior of the data, and then times any random noises. So on the left is the trend of Apple stock price from year through 2008 through 2009, and on the right is the seasonality of Apple stock price. As you see, it has a lot of ups and downs, but it's being bounded. So I use a distribution plot to see what's going on Apple's raw data, and as you see, it has no statistic meaning from this data set so far. And then I implemented a stationary process, which is one of the key process for time series analysis. It would, as I said, the time series data is non-stationary. That means a lot of things change over time. So stationary process would stabilize all those statistic variations or variables by just turning some of the by just taking log of the price point, which would turn it somewhat linear, and then I would use log differencing. So from a high level point of view of log differencing is basically you start from some point and then you take a certain interval and shift it to another time interval. So and that would result that would allow for each time interval the joint distribution would be the same. So as you see from previous slide, after the stationary process, the data would look much more like or behave much more like a random distribution, which is good. So I could use that to I could use the data for any baseline, for example, regressive machine learning model. So it would produce a better result in terms of MSE. One step further is I validate my stationary process using QQplot, which, as you see, like if all the plots is closer to the red line, which is the normal distribution line, it indicates the data is much more close to behave like a normal distribution. So next step, I would start using this method on through the whole data set. And as I said, after I pre-process all the data and turn them into normal distributed data, I could throw the data into an autoregressive model, and then the outcome I could use as a input features or all those, or I should say I store all the parameters, and I could use that for my deep learning model. And finally, I should start my feature engineering step using my raw data to calculate the weekly average price, generate a VPT and momentum for my machine learning model feature. And finally, I would try to look for any macro level factors that might affect the price, such as news, social networks, and this step would most likely implement some type of NLP classifications that indicates how the media talks about the company during the day. If it appraises the company, the price should go up, otherwise should go down. This step would be a still is a theory. It's not for sure to say that it would work, but I'm happy to see if it works. So my deep learning model is actually a reinforcement or actually an enforcement learning model that I would just learning the news over and over to see how the news actually affects the data or the price points. And thanks, and looking forward to hear your feedback. Thank you.